Alright, welcome to your Awesome Tutors video on multiplying and dividing exponents. Let's get started. So when you multiply with exponents, ultimately you're going to add the exponents. But the way I think about it is there's a chain of signs. You go from adding to multiplying and then to giving something an exponent or a power. And when you have an exponent and you're trying to combine two with the same base, I think of it as doing one less in the chain of signs. So like for multiplying exponents with the same base, you add. See, it's kind of one less in the chain. And these do have to have the same bases like I've already said. So let's look at this example. If you have a squared times a to the third, you get a to the fifth because you're multiplying and they have the same base, and so you would add the exponents. And here's another example, a squared times b squared. You actually can't do that because the bases are different. So that's definitely a big thing. You can't combine things unless they have the same base. Alright, so here's a proof for that. If you had 2 squared times 2 to the third, you'd get 2 to the fifth because 2 plus 3 is 2 to the fifth. But how does this work? Well, if you did 2 squared, you would get 4, and 2 to the third would be 8. And so you have 4 and 8, and 4 times 8 is 32. And 2 to the fifth is also 32. So when you do 2 to the second times 2 to the third, you get 32. Let's look at a few sample problems for you to do. So 3 squared times 3 to the fourth, you'd add the 2 and the 4, you have the same base of 3, and you get 3 to the sixth. And then you could do that out or not. And then for the second one, 5 squared times 5 to the third, you get 5 to the fifth. And when you do those out, you get 729 for number 1 and 3,125 for number 2. Alright, so let's look at dividing exponents now. It's kind of the same rules as multiplying, except for you're subtracting. Again, there's kind of a chain of signs. There's subtraction, then division, then you can take the square root of something. And in this case, since we're dividing two bases with the same base with different exponents, we can subtract. So subtraction is like one less than division in the chain of signs. And again, that's just how I think about it. If you want to just memorize that when you divide, you subtract, it's fine with me. So again, they have to have the same base as multiplying. And so if you look at this example, you have a to the fifth over a squared. And so you'd subtract 5 minus 2, and you get a to the third. Because a to the 5 minus 2 is a to the third. And then here's a proof for division, like I had for multiplication. If you had 2 to the fifth over 2 squared, you get 2 to the third, which is 8. But to prove this, if you had 2 to the fifth, you get 32, and 2 squared, you'd have 4. And if you divided 32 by 4, you'd get 8. So it's really the same as if you did 2 to the fifth over 2 squared. For both of them you get 8, and that's how you prove this rule of subtracting exponents when you're dividing. So here's a sample problem. 3 to the fifth over 3 squared. Again, you're going to subtract the exponents, and you have the same base of 3. So 5 minus 2 is 3, so you get 3 cubed, or 3 to the third. And when you do that out, you get 27. And if you wanted to do it the long way, 3 to the fifth is 243, and 3 squared equals 9, and 243 divided by 9 is 27. So that's kind of proving the rule again. Alright, let's look at some additional sample problems. So let's just simplify the first one since you just have variables. So a to the sixth times a to the fifth, same base. So you can add the exponents because you're multiplying. So 6 plus 5 is 11, so you get a to the 11th. And then for number 2, you're multiplying again. You have the same base, and so you're adding. So 7 to the 4th times 7 to the negative 2 just because it's negative doesn't mean it changes. You still add. I also have another video on negative exponents if you need to learn how those work when they're by themselves. So 7 to the 4th times 7 to the negative 2, you add them, so 4 plus negative 2 is just like 4 minus 2, so you get 7 to the second, and 7 to the second, or 7 squared, is 49. Move on to the third one. 4 squared divided by 4 to the negative 6. Again, you subtract because it's dividing, so 2 minus negative 6 would be 8. And you have the same base of 4, so 4 to the 8th. And when you do that out, you get 65,536. And then here we're going to combine, for number 4, we're going to combine multiplying and dividing into one problem. So here you have 4 squared times 4 to the 3rd over 4 to the 6th times 4 to the negative 3. So in this case, I would go ahead and combine the numerator and the denominator, those bases first. So 4 squared times 4 to the 3rd, you add those exponents and you get 4 to the 5th. And then 4 to the 6th times 4 to the negative 3rd, you're multiplying on the bottom too, so you're adding 6 plus negative 3. And then you get 4 to the 3rd, so now you have 4 to the 5th over 4 to the 3rd. And now you can use the division rule by subtracting the exponents because you still have the same base of 4. And you get 4 squared because 5 minus 3 is 2. And 4 squared is 16.
Thanks for watching my video. If you have any questions, please comment or message me because I'd love to answer them. And I'll have more videos coming out soon. If you want any topics for me to cover or make a video about, please tell me. Please subscribe if you like my video and give me some feedback so I can improve on my future videos. Alright, have a great day.